Hello students, and welcome back to the final video of this section and the final lesson of Module 2. In this video we have one more example. We're going to be looking at the connection between the derivative with the original function. In this case we're going to be looking at it when we're given the derivative in graph form. So let's get started. So here you can see that we're given the graph of p prime of x, and we have several questions that we're going to want to go through. And so on what intervals is the graph of p of x decreasing? So you want to make a connection between p and p prime. Well, p of x is decreasing when p prime of x is less than 0. You should recall that. Decreasing, the function is decreasing when the derivative is negative. And so when is that happening? Well, we want to take out any zeros, but it's happening in between -3 to 0, union 0 to +3. So we always want to take out any zeros, so that's why we're taking out 0, but everywhere else in between -3 and 3 is going to be negative. On the other end of that, we want to say when is it increasing? So p of x is increasing when p prime of x is greater than 0. And again, that's going to be something that you're going to want to recall very, very often. Increasing, the function is increasing when its derivative is positive. So where's our graph positive? So everywhere above the x-axis. So that's going to be -∞ to -3, and then everything on the right side of 3. So union 3, +∞. So that's going to be where our graph is positive, where it's going to be increasing. So now we want to continue using that graph, and we want to say what values of x does the graph of p of x reach a relative maximum. So maximums are where you're at the top of the hill, where a function is going from a positive, so when it's going from increasing to decreasing, something like that. So it's going from increasing to decreasing. And so where is that happening? So p of x has a relative max when p prime, so think about it, it's going from increasing to decreasing, so that means that it's going from, the p prime is going from positive to negative. So when p prime changes from positive to negative. Well, where is that happening? So if I go up here to my graph, it's changing from positive to negative at this point. It's going from above the x-axis to below the x-axis. So what we're going to say is at x equal -3. And now we want to take a look at the relative minimum. So p of x has a relative min when, well, you want to think about what creates a relative minimum. So that's going to be where the graph is going from decreasing up to increasing, and because now you have a bottom point there, and so decreasing means negative to positive. So when p prime of x changes from negative to positive. All right, so let's look at our graph again. Well, the only time where it changes from negative to positive is at x equals 3. You don't want to say at x equals 0 because it's changing from negative to negative. That's not what we're talking about. We're only talking about when it's changing from negative to positive. So that's going to be at x equals +3. And so finally, we want to approximate the value of p of 1.8 using the approximation, using the tangent line approximation of p of 2 equals -3. So let's start with getting our tangent line so that we can make this approximation at p of 1.8. So our point of tangency is going to be 2, -3. And so my slope of the tangent line for this is going to be, well, I need to grab it from 2. And so my x value is 2, and so p prime, my slope is going to be -4. So my slope of the tangent line is going to be -4. And let's write out my tangent line equation. So I'm going to have y plus 3 equals -4 times x minus 2. And now I'm going to use that and substitute 1.8 to make a tangent line approximation for 1.8. So y plus 3 equals -4 times x is going to be 1.8 minus 2. All right, so let's solve for this. So I'm going to get y plus 3 equals -4. 1.8 minus 2 is going to be equals -4. And that's going to be -0.2. And I'm going to get y plus 3 equals +0.8. And then I subtract 3 from that. So I'm going to get y equals -2.2 right there. So what are we going to say? Well, our tangent line is being used to approximate p of 1.8 because 1.8 is pretty close to 2. You know, we probably wouldn't want to get too much further than that, but you know, 1.8 is fine. And that came out to be approximately -2.2. And that's going to conclude the final lesson of this module, module 2. And you're going to really want to make sure that you have this in your brain. Increasing means positive derivative, decreasing means negative derivative. You want to make all these connections in tabular form, in graphical form, and using sign charts and using and understanding the analysis from functions. Make sure you guys get that down. If you do need any help, I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.